Well, hi, and welcome to my shop here. It's July 1st, Canada Day in Canada. So let's see, I changed now all the electrolytic capacitors in here, and I changed the diode detector. And the radio sounds better, but doesn't sound perfect yet, or as perfect as it should sound. So I've set my sights on 3 more little capacitors. We're going to take a look at these. These are green colored capacitors. Can you see them there? You can, kind of. One here, one over here, and there's one there. Now, I've looked at these as best I can. I'm not sure if they actually have their sizes written on them. So I spent some time yesterday evening in here trying to relate the components on the board here to the schematic that I'm looking at, and I think I had success, but I spent an hour just sorting out those 3 capacitors. So the first thing I want to do is review verify that I got it right before I start changing these capacitors and putting in wrong sizes, and then I'm going to change the 3 of them and see if that doesn't clear up the last bit of fuzziness in the audio of this radio. So okay, so this I don't know if I should even put this on video because it's an awful lot of silence and looking. So I think maybe what I'm going to do is I'm not going to video the process of me double checking this stuff. I'm just going to do it, and then we're going to get into the replacement part of it. Okay, so there's the little capacitor. Let's just check it. It says right on it 0.005, which matches with what I figured it was. .006 0.006. D lost nothing. So nothing wrong with this capacitor. Phooey on that. Okay, the replacement is here. Just be sure it's good. Point 4,500 picofarad. That's just a little under. Okay, well, that's too bad. That's only one of the 3 of them, and the only way, to do this is to take them out and test them and see what's up. The only way to be sure. Okay, that's done. Now the next little capacitor doesn't look as good as that last one. Yeah, it looks like it's damaged at the end here. Would that ruin it? Well, it's certainly not going to help it any. Okay, let's see if we can get that one out. Oops. Now I can probably pull that with my fingers. Okay. See if we can, yeah, looks like we can read this one too. Let's see what it says. One just says 100. 100 what? Pretty clear 100 on there. Okay, 100, eh? Would be 100 picofarads. That one I think is C4. C4 10,000. 10,000 picofarads. I don't think this is C4. Okay, so I'm going to do a little searching. Now that I have it out, I know for sure which pads it was on. I'm going to check and see what capacitor it really is. Well, it's pretty convincing that it's C4 and it's 10,000. 10,000. How do you get a 100 written on there? So we're going to test this capacitor, but it's in worse shape now than it was when it got damaged on the way out. Well, let's look at that. The lead has come right off it. Oh boy. Yeah, I'm not sure I can do anything valid now with it. Fingers are all over it here. Well, gives that's 10,000 picofarad. Huh. Okay. Well, it's reading. It says it's 10,000 on the thing. It reads 10,000, even though it says 100 on there. Okay. So that makes it a 10,000 picofarad is a 0.01 microfarad capacitor. Now, didn't I have one out here? Just check and see. (10 nanofarad, which is 0.01 microfarads, just 10,000 picofarads. So this guy will go in, take the place of what apparently was an okay capacitor. Again. Hard to push on this. There we go. Soldered. Pulled the trace right off here. That's bad. Okay. Every time you work on one of these old radios, everything you do, there's a risk that something's going to go wrong unexpectedly and you're going to end up in a worse position every time you do something. That's how I see it. It looks like the traces didn't break. Okay, one last one to do. end of it. There. Stuck between components here. There we go. There it is. Okay, we'll take a look at this. .005 or 6. There's the 100. So the 100 is the voltage. .005, I would say. This is, have a look at the schematic here. This is capacitor number 23. See the red dot there? I proved this out by identifying all the adjacent resistors, 11, 13, and 10. So there's no question, this is C23. So let's look at C23 in the capacitor list. I'll start at the very top. 1, 10, 20. I'll go to the top of the list over here. 21, 22, and there's no 23 listed in this thing. Nowhere is there a 23. Just to make it even more confusing, see the R23? So the way this thing is numbered, it starts at 1, over here, and it works its way up in numbers. So by the time you get over this part of the diagram, you're looking at R18, R19, C20, R21, R24. Where's 23? I spent quite a bit of time looking for it, back and forth. It turns out it's way over here. Poorly written 23 on the volume control, basically in the middle of the schematic. What happened? How come they numbered this 23? I mean, there's our 10 right there. 23. So my only guess is this was a late addition to the whole thing. They had already drawn this schematic. They didn't want to renumber everything. They had this list already written and all that kind of stuff. And some senior engineer said, you know what? You got to stick 1,000 ohm there to stop oscillation. That's my guess. That is 1,000 ohms there right on the volume control. And my guess is it's an oscillation blocker that was missing in the original design. My guess. I don't know. I like making up stories about these things. There is a story behind that, I'm sure. But I'm not so sure I know what it is. So what did I conclude that was as a capacitor? What did I say it was? It was another .005. Okay, well, we'll stick in a .005. Okay, there's number 3. I was just thinking while I'm doing this that these guys were installed with almost no lead at all, and the capacitors I put in are a little larger, like they're standing up, and there's more lead there. I sure hope that doesn't cause problems. But we're ready for a test. We are ready. Okay, Not off yet. Okay. Switch is off. 5 volts there. What do you do this time? Weren't we on a station there last time? Well, I think it has exactly the same fuzzy sort of sound to it. Again, you could listen to this radio, but it's not where it could be. And what's left now? Whew. Well, there's nothing in here I'm looking at that makes me think, ooh, I should try changing that. We're at the end of that road. I did try testing some of these resistors. It became just a nightmare to try to do it. They all look perfectly fine. Doesn't guarantee there isn't some high resistor in there or something that's open circuit even, although the radio does work to a fair degree. There's a remote chance what we're hearing is the result of bad alignment, but I think that's very remote. And you know, if these things weren't waxed up, I'd be more inclined to play with them right now. But no. So a couple things we can do here. Once again, we can put a signal on the antenna, and we can examine the quality of the signal as it travels through the radio. Another way is to inject signals into the radio, especially audio. You know, we could do that. We could inject audio into the audio amplifier part of the radio. Listen to what it sounds like and see if the distortion is there. I like that idea. I'm going to do that idea. I'm going to get some coffee first. Okay, well, when it comes to injecting audio in a radio like this, obviously the best place to go is right to the volume control. There's the volume control. All I got to do is just inject some audio across it, and the volume control will control the amount that's fed into the rest of the amp. So that's basically what the radio does. The radio is providing audio to the volume control across the volume control, and then the slider is picking off a portion of it to carry on through the radio. So the other thing about the volume control is, hey, it's right there. I mean, it's no problem spotting it and figuring it out. Now, it's going to have a grounded wire, and then it's going to have the signal wire, and then it's going to have the one going out. I'm pointing to the black one as the grounded wire because most of the time that's what happens to a black wire. And you know what? I think I can see it going down there. Let's just take a look. Yeah, right down to the ground. Okay, so we'll not get confused. Pick this. This is coming from the signal generator right up there. Too many tools around, Jim. Clean up a little bit. Actually, I'll just put the mess over there. Okay. Easy to go on right here. Now, the radio itself will still be producing sound. It might be diminished greatly because of this connection, but there may be radio sound in here along with the signal generator, which I think I have set from yesterday, whooping up. I changed the frequency right at the very end here. Just bear with me a second while I... Oop. Why am I not seeing it? Help me now, help me now. Start frequency is... There we go. Now I know what I'm doing. Stop frequency 10. Start frequency... that would be 2... Let's start there. Okay, does that make sense? Did my muttering come across? I don't know. Okay, I'm going to turn the radio on. I still have power to it. Power's connected. Here we go. Oh, hot diggity dog. There's our tone already. Let me turn this down. That's much better. Okay, and we'll make it sweep. We'll slow it down. Ten kilohertz. 1, 2. I think I can hear that up to 6 kilohertz. Sounds pretty good to me. I really want to listen to the lower tones though, so we're gonna do that. Let's turn it up a little bit. So there's definitely some distortion in this. But I don't know that it's the same distortion we were hearing before, and it could simply be I'm just overdriving this. Let's see, we're at... No, I don't think so. I think the volume coming out would be similar to what you would expect from the radio, so I don't think I'm overdriving it. I'm going to attach it right to the speaker so we can hear what it sounds like right without the amplifier in the middle here. Okay, so we'll power this off. The question is, does it sound any different? Sure. Yeah. That has a proper sound to me. That sounds like a nice sine wave. Why don't we look at it on the oscilloscope just to see what it looks like. So we'll be looking at the speaker. That's a funny sound. Okay, scope connected. I can't trigger on a, this is not triggering well at all anyway. Have a look at that. I'm just going to jam the camera over that way. Now you should have seen enough there to see it's not a nice sine wave at all. So there's definitely something more going wrong here. So I should try to inject this signal closer to the speaker. Because right now we're using the volume control. We're involving this transistor, and these two. So yeah, stage, a stage, and another stage. The problem is probably caused in one of these stages only. Provided. So what I should do is try to inject it across R14. R14, how big is R14? R14 is 5600 ohms. You know, the output of my signal generator is very, very low. The impedance is very low, so I'd be dropping this impedance. I'd be messing around with the bias here. My signal generator does have a feature where you can offset or provide bias right on the signal wire for these kinds of situations, I believe, but I have no experience in doing that. Maybe there's a better spot for me to try to inject the signal. So, you know, ideally it should just be into these two last transistors. So that would be well, I really want it to come out. I guess it's got to be, you know, these aren't push-pull, so you can't be feeding the same signal into both grids. So you have to do it through here. You really have to do it back here. Maybe here, maybe here. Bias problems and everything. Inject the signal through a large resistor, through a larger resistor. Because what did I say? 5600, that's not very much. I take like a 10K resistor, stick it on the end of the signal lead. That would probably be sufficient. Then we got to find this spot. R14, R15, R14, 56 and 10,000. There's lots of those in here. I'm looking for something unique that I can grab onto. So C17, we're just eyeball the base from the transistor here. Eyeball the base. What just popped on the radio? It's probably just one of my leads here. So the two output transistors are here. This is almost certainly the driving transformer. Speaker leads are hooked up to this transformer, so this is definitely this one. But could feed it in on the primary side here from this transistor, if I could figure that out. So it's probably this transistor here. How am I supposed to recognize which is which? Down there. So there's a capacitor right there. That's probably the C17, but I can't be sure. I think I can read the number on that transistor. The transistors in here, there's three types. 2T7, 2T6, and 2T8. Well, then the well, I don't know, if I feed the signal in the wrong spot, is that really a problem? Yeah, this isn't a, there isn't 20,000 volts inside this radio, just a few. Okay, so I need a little bit of protection here. A resistor and a capacitor is what I was thinking. Such a thing here. Where is it? Okay, so it's missing. Son of a gun. So I have capacitors galore. Take this capacitor and I don't remember what the heck I'm trying to do. I'm trying to inject the signal later in the radio. Take this off. Just need the right kind of resistor here. Basically any old resistor. That's not a resistor. Well, I do have a lot of resistors. Grab one, Jim. How about this great big piece here? Okay. So 3,000 ohm resistor here. What I'm going to be trying to do is touch this big long thing here. I'm aiming for the base, but really I'm guessing too, guessing the transistor and the signal. I'll knock it down a little more. Okay, so I'm going to touch leads on a transistor down here and we'll see what happens. Nothing there. Bingo. Okay, a little more power. Now, I think I can turn down the radio here. Wow, I can't turn it very low. Turn it to a quieter spot. Okay. I think what I managed to do was touch the base of that transistor. I'm going to do it again. Look, you can see it on the scope. Lots of the same, looks like the same sort of distortions in there. There's a good chance the test itself is generating distortions, but fed the signal into here, I'm pretty sure. could have been going in here. I can't be absolutely sure. Yeah, it's really tricky to be sure. I mean, there's no components between the primary winding here and this transistor. Yeah. So let's assume this is then proven. Let's assume it's proven that the problem is here, 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 or somewhere in here. It's this diode here. I never found this diode. Yes, I did. I found it hidden up under one of the legs of the transistor here. Can I verify this diode is good? D2. Ooh, varistor. It's a varistor. A variable resistor. They're usually temperature dependent. I'm not quite sure what this is here for. I believe it has to do with biasing these two guys, but not sure. It's showing a diode symbol, but it's calling it a varistor. That doesn't work in my book. And my book is probably wrong, by the way. So, so what could we do here to find out if there's something out of sorts? Well, there should be some bias voltage on these two guys set up by this diode, or whatever it is, varistor. So there should be some voltage setting here. The other thing I could do is I can look at the signal coming through with the scope and the output of each of these transistors and see where, that's a better idea. I like that idea. I'm a little more comfortable with that because I can feed the signal back in the volume control and look at it as it comes out here and out here. That might help me kind of narrow down where the problem is. Okay, that's a good idea. So again, signal back into the volume control. Okay. And we want to listen to it now. Or look at it. I think looking at it on the scope is a better way to do this. Various places in there. Okay, so I'm just going to set up a better camera on the oscilloscope so you can really watch it here. Okay, you can see the scope up in the right hand corner there. Now, what I'm going to try to do first, because it's pretty easy, is look right at this spot here. And that's going to show me the signal, I think. It's going to show me, maybe show me nothing there. Well, I'm going to look there. But probably I should be looking here and here, outside of the transformer. See what kind of signal is getting to these transistors. Okay, and that's easy to do because the three legs of the transformer are exposed here, so we're going to go center one. There. What do we get? Okay, this might not be the best place to look. Not much of anything there. Those peaks that you can see along there, along with you have a somewhat normal sine wave, and then there's these peaks. I think you can hear those peaks as spiky little interference. Why is that there? Let me change the input level. See, they're still there. Oh wow, that's pretty weird looking. We weren't on exactly the best place to look. Couldn't tell you anything about distortion there. Let's go on one of the transformer legs now. Scope may be interfering with it. Oh, what do we got there? What's all that stuff? Well, why does it sound so different? I turn this input now. I have this turned way up. Yeah, this is a better way to do it here. Okay. Let's go back. Start over again. Center lead. Nothing at all. That's kind of what I would expect there. Now on the outside, here we are. Well, that doesn't look right, does it? And the other side, same thing. Okay, not sure what to make of it yet. Let's look at the input. So we're looking here. Let's go on the other side of the transformer. Distorted there. So we're working our way. So now we're looking here. We're looking here. Let's see if we can get to here. That's a little trickier. There's the transistor. Well, no idea what leg I'm going at or anything. But there's one down here. You heard me touch it there. Nothing there. Now, can I get at the other legs here? There's one there. Nothing on the scope. How come nothing on the scope? And then the one in the middle I can't really get at. So that's probably the base I can't get at. Try that again. But I don't know. I don't know which leg I'm testing. Just tap the capacitor lead there. I can't really get in at it. So what's happened here is I can't really can't like get ahead of this. Can't find this. Okay, well, let's look at the output from the volume control. Yeah, that's checking my signal generator, make sure it's not set for a triangular wave. That's output of the volume control. A little bit of trouble seeing this without blasting my ears off. So that's what's coming out of the volume control. I can look at what's reaching the volume control. By that point, you know what I'm looking at. I'm looking at the output of the signal generator. It's really all I'm doing at this point. There you see a perfect sine wave. Sine wave here. I'm just going to cut the shop volume to nothing for a moment, turn this right up, see what shows up on the oscilloscope here. I tell you, it sounds like dive, dive. My wife's going to come running down here. What's happening? Yeah, no, she knows what's happening. So what I saw when I did that was a very nice sine wave. And that's no surprise, because it's basically got to be okay there, doesn't it? So we've got it okay at the signal generator injection point, of course, here. Not okay here. Haven't been able to poke around in here yet. See? So I've replaced this capacitor. So one side of it, the side that's on R13, 1000 ohm side, get on the 1000 ohm side of this capacitor. I'm on the output of that transistor. Oh, that's okay. Looked good when it was on the schematic. Where am I on the actual circuit? C23. It's one of the ones I did this morning. C23 is this guy. Okay, that's easy now to get clips onto it. I'm not sure which end is which, so we'll just try either end. Oops. Oh, what do we got there? Now that looks more like an oscillator, like the local oscillator. How is that possible? Local oscillator. I think that doesn't make sense. There shouldn't be any oscillator stuff out here. Uh-oh. I don't like it when things really start falling apart here. Don't make sense. Let's go on the other side of this one. Same capacitor. There we go. Well, not what I was expecting, but it's just because I don't really know where I'm connecting in the circuit. So this would look like something in the mixer, I almost said mixer tube. In the mixer transistor, can you call it that? How do I do the mixing in here? Mixing in some kind of a coil or something. In any case, that looks, you know, as hard as it is to look at this thing, it looks to me like a good sine wave. I'm going to drop the volume and up the volume again. Okay, it certainly is odd to me, but that's okay. The signal at this point is good. That's what I would say. And what point are we at? We think I'm somewhere up in here. So I could be on the input side of this transistor. I could be on the output side of it. The input side is, you know, I could start measuring voltages here, DC voltages, start sorting out which is which. Maybe I need to really hunker down on this. Let's just review what we found here. One thing we haven't proven yet, I should do this next, is that the radio sound coming out of the radio is good. It's getting messed up in here. We listen to it here. We need to listen to it here. And the best way to do that, I guess we'll use my little signal tracer, and we'll put it right on here. See what we hear there. Okay, signal tracer. I'm going to use the one that's over here. I think I said that this is just for audio, but I think that's wrong. I think it can do RF also. Now, to get this guy to go, I need to hook him up to the ground. It's getting a little busy on the radio here. So I'm going to take the scope off. That sound different there for a moment. Okay. Put this ground on here. And we're going to try to listen in that same spot. Where's that spot? Oh my god, yeah, it's a capacitor here. Okay, don't know what's going to happen with the volume. A little bit of DC there, I guess. We'll go over here. Okay, so it's coming out of the signal tracer, but the problem is we've got competing volumes here. You can hear this speaker and the other one. I'm ahead in the game. Yeah, I'm literally ahead in the game because compared to you, I'm hearing everything in beautiful three-dimensional sound. So I would say the sound I'm hearing coming from the signal tracer is perfect. It starts lower too. So that's here. So if we listen a little further on, somehow, how do I get over here? Well, let's go over where it doesn't sound so good. So we'll try to find this spot again, the primary of the transformer. Pretty loud. Turn it down. Whew, still pretty loud. I don't think it's distorted. So that was at this point. Before, I'm pretty sure, didn't I put the scope on there and it looked bad? Well, let's hear on the other side here. The inputs here, if I can do it. That'll be very loud, I would imagine. Everybody hold on to your ears. So that's on the input to the base of the output transistors. So that's got to be over here. There's one. There's the other one. I don't know, boy. That's a tough one because I think it sounds the same. So on the input side, and the output side. Okay, and then we'll go on its way now to the speaker. So So this is what's really being shot at the speaker here. That sounds distorted. So what we're listening to there listening to the input here. Whoop, 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 danger, danger. Ground is off. It's interesting how adding something to the ground affects the antenna. Oh, diggity dog, how'd that get so loud? I turn this up. Oh my gosh. This very strange thing just happened there. What is he doing? He's doing this. I'm just... These are just pad buttons. They're just reducing the output. So why it's making so much fussy noise? So I've gotten just a little overwhelmed with everything here, so I think it's a good time for me to stop right now and just ponder all this. I'm not getting any really clear indications. I'm starting to get fuzzy thoughts in my head, and I can't work with fuzzy thoughts too much. Yeah, I gotta stop for a while here.